Good day everyone, I am Lara and I am a student nutritionist for today. So for today's video, I will discuss about the biomolecules present in the dishes the staffs had picked. What dishes? Some Greek dishes, Mousakka and Baklava specifically. For now, let's jump into the dishes. First, Mousakka. Mousakka is an eggplant or potato based, often including ground meat in the Levant, Middle East. Its ingredients are eggplant, salt, olive oil, butter, ground beef, onions, garlic, nutmeg, white and black pepper, tomato sauce, red wine, egg, milk, all-purpose flour, and Parmesan cheese. Second dish is baklava. Baklava is a dessert originating in the Middle East, made of phyllo pastry filled with chopped nuts and soaked in honey. Ingredients are phyllo dough, chopped nuts, butter, water, white sugar, vanilla extract, and honey. Now, let's identify the biomolecules present. Here are the ingredients of Mousakka and baklava. Well, as you can see, I mixed them all up so that it will be easier to identify. Under the column of carbohydrates, eggplant, nutmeg, cheese, tomato sauce, milk, all-purpose flour, phyllo dough, white sugar, honey, and red wine. Under the column of proteins, ground beef and egg. And last, under the column of lipids, olive oil, butter, and chopped nuts. There are 4 types of biomolecules: carbohydrates, lipids, proteins, and nucleic acids. But I will only discuss the biomolecules present in the dishes I've mentioned earlier. Carbohydrates function as energy and form part in the structures of some cells and tissues. Classified into 3. First, monosaccharides. Monosaccharides is a simple sugar that provides ready source of energy. To form a monosaccharide, it should have 3 to 7 carbon atoms shaped as a Plato's chip, just like this. These are some examples of monosaccharides, glucose and fructose. As you can see, they really look like Plato's chips. These can be classified as triose, tetrose, pentose, or hexose, depending on the number of carbons and the position of carbonyl group. Second classification of carbohydrates is disaccharides. Disaccharides is also under simple sugar and function as sweetener, dietary component, and energy source. Disaccharides are formed by dehydration synthesis or removing of water, bonding 2 monosaccharides, thus form a glycosidic bond. Here are some examples. Sucrose and lactose. The picture says it all. How do sucrose or table sugar form? By bonding glucose and fructose. Both are monosaccharides. As well as bonding galactose and glucose form lactose or milk sugar. The last classification of carbohydrates is polysaccharides. Polysaccharides is under complex carbohydrates and function as storage for monosaccharides. Polysaccharides are formed by bonding hundreds to thousands of monosaccharides. For example, cellulose, starch, and glycogen. Next to discuss is proteins. Proteins have a lot of functions, such as enzymes, balance, synthesis, antibodies, etc. Proteins are formed by linking amino acids that form peptide chain and peptide bond. It has a central carbon atom, an amino group, a side group or R group, and a carboxyl group. Amino acids differ from their R group. In addition, there are 4 types or levels of protein structure. First, primary structure. It is the amino acid sequence only. Second, secondary structure. It is the interactions between stretches of a polypeptide chain and includes beta sheet and alpha helix. Third, tertiary structure. It is the 3-dimension folding by interaction between R group. Lastly, quaternary structure. It is a protein consisting of more than amino acid. The last one I will discuss is lipids. Lipids are organic compounds and are insoluble in water. Function as energy storage, cushioning vital organs, and serve as precursors for important reproductive hormones. Has two main components, glycerol and fatty acids, bonded by dehydration synthesis and formed an ester bond. Lipids have three groups. First, triglycerides, function as energy storage and insulation. Consists of three long hydrocarbon chains connected to one glycerol. There are two types of triglycerides. First, saturated fats. It has a linear structure for close packing, has one bond, also known as trans. It is mostly solid, so the perfect example is butter. The second type is unsaturated fats. It has a band structure to prevent close packing, has double bond, also known as cis. It is mostly liquid, so the perfect example is oil. The second group of lipids is phospholipids. It is the major component of the cell membrane. This is a phospholipid. As you can see, the head is hydrophilic or attracted to water because it is composed of phosphate group and glycerol. And its tail is hydrophobic or water-fearing because it is composed of saturated and unsaturated fatty acids. The third and last group of lipids is steroids. It functions as base material for sex hormones, emulsification of fats, and maintains the fluidity of the cell membrane. Steroids have four fused carbon ring structure. Its structure is different from other lipids and yet still considered as lipid because of its insolubility in water. For example, cholesterol and cortisol. That's all for today. And again, I am Lara, your student nutritionist for today.